time a little bit, and we left off on the cost one. So we were trying to minimize the cost of constructing a box whose base length is 3 times the width. The top of the box is more expensive, so the top and the bottom cost $10 per square foot, and the front, back, right, and left cost only $6 per square foot. Okay, so we had set up our equation. We have our cost equation, and then we realized we needed a secondary equation. So that secondary equation we could solve for h in order to plug h into the cost equation. So we got to that point right here where we were getting ready to plug in for h. You guys with me? All right, so we're going to plug in to our cost equation. Instead of having 60w squared plus 48wh, we're going to replace the h with what it's equal to. So it's equal to 50 over 3w squared. We're then going to reduce out. So I'm going to reduce the 48 and the 3. And I get a 16 when I do that. And I'm also going to reduce the w and the w squared, and I have a w on the bottom. So this simplifies to be 60w squared plus, and then 16 times 50 is 800. So 800 over w. So instead of writing 800 divided by w, I'm going to write that as 800w to the negative 1. Does that make sense? Okay, why would I set it up that way? Yeah, it's easy to take the derivative. I don't have to do the quotient rule. All right, so when I take the derivative now, because I'm trying to minimize the cost, right? So if I minimize a cost, I have a curve, and I'm trying to find the minimum, which is where our derivative is equal to 0. We talked about that last time. So I take the derivative, and I get 120w minus 800w to the negative 2. Which is really 120w minus 800 over w squared. And so I've told you that maximums and minimums can occur when our derivative is equal to 0 or when our derivative is undefined. Okay, so we need to find any critical value from the numerator equals 0 and the denominator equals 0. So a lot of times when we have things like this that involve a fraction, what I'll have you do is I'll have you combine them into a single fraction. So we're going to do that. So I'm going to multiply the first one by w squared over w squared, so that I can rewrite this. I don't think, it will be w cubed in the end, is that what you're saying? Like, so it's going to be 120w cubed minus 800 all divided by w squared. Okay, so I need when the c prime equals 0, but also when c prime is undefined. So c prime is equal to 0 when that 120w cubed minus 800 equals 0. And c prime is undefined, that's the second part of it. Well, that happens when w squared equals 0. So we're setting our numerator equal to 0, and we're setting our denominator equal to 0. We're setting both of them equal to 0,
but
right?
If, like on the homework, I don't remember if you said to go to 4 grade 6, but I went to 6, and in one of those problems it asked for like, what is the combination, and I didn't solve for the denominator because I assumed that would be a logical answer.
Sometimes they are not logical answers. So if I got like a w was negative or something, I can't have a negative with.
So like what he was asking, I figured it wasn't that wasn't one of the possibilities he was looking for.
All right. Whoops, I didn't get 6.6 repeating. I got confused there. Okay, and then raise the 1/3. So when I do my 800 over 120 and then raise the 1/3, I get 1.882. I don't know. We'll talk about that already, like what ones are good and what ones are bad. I did the cube root of like 800 over 120. So 800 over 120 ends up being 6.6 repeating, and then I did the cube root of that. So on a cube root on the calculator, the easiest way to do it is raise it to the 1/3 power. That's like the quickest way. Okay, so that's one of our critical values, and the other one's 0. So Ari, I think what you're asking is like sometimes you get values that don't make any sense. Well, if I plug in anything to the left of 0, like that doesn't matter to me, does it? I'm not going to use a negative with. So I just kind of put an X there. I'm not even going to look at those. But I need to check to see if c prime is negative and then positive or positive and then negative. And that tells me if I have a max or a min. Okay, so if I want a min, I want this to go down and then up for c, right? So I plug into c prime. And I would plug in here. So, yeah. So I plug in the numbers next to the critical value. So if I plug in like 1, I get 120 minus 800 over 1 squared. Is that positive or negative? Negative. Multiple people that said positive, and Nick's the only one that was like negative. So, because it's 1 cubed, right, times 120. So 120 minus 800 is negative. over a positive number. And then if I try something like 2, well, I get 120 times 8, which is bigger than 800, minus 800, so I get positive. So that means that my C, my cost function, decreases and then increases because C prime was negative and then positive, right? So we write that somewhere. We say C prime is less than 0 on 0 to 1.882, and we say C prime is greater than 0 on 1.882 to infinity. Therefore, there's what? A minimum. Minimum cost at W equals 1.882. So what is this telling me? This is my width. That's why I use W, right? So it's my width. I'm in feet. And the question said, what are the dimensions? Exactly. So we want to know the dimensions. So dimensions we always do like length times width times height. So like if I talk about I don't know, like a plank or something, you've heard people say like 2 by 4, right? So it's 2 by 4, right? So with a volume we're going to have, yeah, I know, what's the width on a 2 by 4? I don't know. Oh, is it? I didn't know that. All right, so then we need to do the dimensions. So we need to do length, width, and height. So we always have those little X's in between, right? So we're going to do 1.882 feet by, and then we go back and we plug in. So we have 3W and H, right? So 3W is that number we just had times 3. So we get 5.646 feet. And then the H, if you found where we had solved for H, it was 50 divided by 3 times our W squared. So that's where it's nice if you have the calculator where you can like go back up and grab, or maybe if you can't, then you should store when you're getting your answers because a lot of times you have to use those answers. And with calculus questions on the AP exam, sometimes you could be off by a lot. So we always want to store. All right, so those are our dimensions. Make sense? Okay, so let's try another one from the beginning. So hopefully that will help because we kind of started in the middle of that one. Okay, so a printer needs to make a poster that will have a total area of 200 square inches and will have a 1-inch margin on the sides, a 2-inch margin at the top, and a 1.5-inch margin on the bottom. This is like how I write letters of rec. 2 inches on the top, 1 point. So this is where I got these numbers, I guess. So we have this poster, and the total area of the poster is going to be 200 square inches. But then we're going to have a margin along the top and the bottom, and then a margin on the sides. So along the top, it's going to be 2 inches. On the bottom, it's going to be 1.5 inches. And on the right and left, it's only going to be 1 inch. Okay, so we want the whole poster to be 200 square inches. Well, that could be like our length times width, base times height, whatever you want to call it. So let's say we call it base times height. So our base times height is going to be 200. Do you think this is the equation that I'm trying to maximize or minimize?
No.
So read through the question. What does it say when it talks about maximum or minimum? It says we want the dimensions of the poster that will give the largest, so maximize, largest printed area. Okay, so this poster is printed. Here's the printed area, right? Does that make sense? So we need to figure that out. And you'll see these questions all different types. So I've put this on, like a question like this on the test before, but I flipped it around. So sometimes I say, well, the printed area is 200 square inches, right? And then you have margins on the outside. So you need to be careful on which one you're doing, like with the B times H equals 200. I always make this the easiest way possible, the secondary equation. Yeah?
So then, your primary equation, right, you would have like, also it doesn't matter what variable you set it equal to, do you usually use C? What do you say?
I would use A for this one because it's max printed area, right?
Would you do like A equals like H minus 3.5?
Uh-huh.
B minus 2.
Yep. Do you guys see where you got that? So he's saying that if we had B going all the way across there, then this distance is going to be B minus, and we subtracted 1 and 1 from each side, right? So B minus 2. And he said if this whole thing is H, then this part's going to be h minus 2 from the top, 1.5 from the bottom, so minus 3.5. Make sense? So the printed area then is going to be b minus 2 times h minus 3.5. Okay, so we need to solve for either b or h. It doesn't matter. Yeah, Meredith. 3.5 because there's a 2 along the top and a 1.5 on the bottom. So you're taking out, so like this distance, so this whole thing, you take out 2, so cut this part out and cut this part out, and you have 2 and 1.5, so a total of 3.5. All right, so we need everything to be in terms of one variable, so we need like a equals, and we only need h's or we only need b's, and it doesn't matter which one you do. Yeah?
Well, first of all, when you multiply, if you were to multiply those two together,
You could multiply those two together.
the h and the b will come together, and you can just immediately, first of all, just get rid of that one.
The h and the b don't go, you would still have b times h.
Yeah, I'm saying you have b times h.
Oh, so you're saying you replaced it with 200. Yeah, you could do that.
That's just one
That's
of
true. All right, so let's say we didn't know that and we'd solved for, like, b. Okay, we'd have 200 over, or I said b, but I wrote h. So 200 over b equals h. Let's say we have that. Then as I start replacing, I have 200 over b minus 3.5 times b minus 2. So we can take the derivative at any point. Like, we have everything in terms of b. But this would be a pretty complicated derivative, right? Because we're going to have to do product rule, and then we have a denominator as well. So either quotient rule or change that to b to the negative 1. I would probably multiply it out. So I'd go ahead and FOIL out first. So notice when you do 200 over b times b, do you see what Ari was saying? Oh, I'm going to get 200. Because that was really just b times h before if you had FOILed previously. So we get 200 minus 400 over b. So I'm going to write 400b to the negative 1 minus 3.5b plus 7. Right, when you take the derivative, it goes away. Ari is very excited about learning today. He is all over it.
No, cool, I don't need your stats.
So he's saying when you take the derivative of 200 and the derivative of 7, it doesn't matter. Like, you get 0. So those go away. Yeah, Phil. No, because the negative 1 times negative would become positive. Nice.
Oh, okay.
That's all right. Good looking, though. Looking for it. All right, so we want to go ahead and get common denominators. So right now we have 3.5, but I want to multiply by b squared over b squared. So I can combine. So my a prime is going to be equal to 400 minus 3.5 b squared divided by b squared. So again, we set our numerator equal to 0 and our denominator equal to 0. So we want to find when both a prime is equal to 0 and when a prime is undefined. So a prime equals 0 when we have 400 minus 3.5 b squared equals 0. So we find that. I take my 400 divided by my 3.5. I take the square root. I think we get like 10.690. So I'm going to store that just in case I need it to find other dimensions. So I store it as a. And then the other one is b equals 0, which makes sense, right? You can't have negatives, so that's why that's there. So when we test an a prime, I have 0 and I have 10.691, and I really don't have anything on the left of 0. I can't have it like a negative for my length. All right, and then we test in the first derivative. So if I test like 1, 400 minus 3.5 times 1 squared over 1. Huh? Oh, 690. Thanks. All right, when I try 1, it's negative, and then when I try, is it negative? I got positive, and then it's negative. So increasing and decreasing, is that what we want? Yeah, we wanted to maximize our area, right? Okay, so we quickly write a prime is greater than 0 on 0 to 10.690 to please the AP graders. I can't remember what you guys called them the other day, but you had some kind of word. The master overlords, yes. All right, so that means that there's a maximum. Max printed area. And it's probably asking for the dimensions again, right? So what dimensions of the poster? with dimensions of poster of, I don't know how to say that, of B, or yeah, B was 10.690 inches by, and then H, we have to find H, huh? Oh yeah, the little 3 dots. All right, so 200 over B. So I'm going to do 200 divided by my answer, and I get 18.708
So you
inches.
just put that back into the secondary equation?
Yeah.
So this is the paper size that we shouldn't use when writing essays. Instead of these.
Yeah, wouldn't that be nice? 18. Yeah, that's true. He's saying it's the paper size that you shouldn't use when you're writing essays if you have to have a certain margin, because then you'd have to have the most words on that. I agree with that, Cole. Good thinking. But if I'm trying to fit as much as possible, so if I'm trying to give you guys a test and I want as many questions as possible, I should use that size of paper. All right. I know, wouldn't that be nice? All right. So the next one, so a window is being built, and the bottom is a rectangle and the top is a semicircle. So I don't know if you guys have seen these windows before. This is called a Norman window. Okay, so these little, what I want you guys to do here is not have this line here and just do like a dotted line across. Because we're talking about the framing materials for this Norman window, and if I'm going to frame it out, it's just going to go like around this way. Does that make sense? And these Norman windows could be really tall or they could be really wide. I don't know how it just depends on the window. Okay, so what I typically do is I let this distance be R. Instead of doing like the whole distance, like what I've done in the past is I used to make this X, but then I had half X for my radius, which was a little bit weird. So what I recommend is to use the R when you're doing this problem. Okay, then you have one like this in your homework too. All right, so it says, what dimensions of the window, what must the dimensions be in order to let in the most light? What does that mean? Yeah, maximum area. Okay, so let's talk about the area of the window. Yeah, it's a real fun area problem. I agree. So we have a semicircle and a rectangle. Well, I know this distance down here. 2R. But I don't know this distance, so I'm going to call that H. A lot of times things end up being squares when you're trying to maximize area. Did you guys find that on the first few on your homework where you're like, these are always the same? A lot of times it's squares. This may not be a square, though, because the weird thing on the top. All right, so our area of this window is going to be the rectangle plus the semicircle. So the rectangle is going to be 2RH plus the semicircle. I don't know. What is it? Pi r squared. It's area, right? Pi r squared. Remember, area is like square feet, square inches. It's the one with the square. He didn't hear that at all. I told you a way to remember it.
I registered, but I don't know.
If there are 12 meters of framing materials, so 12 meters of framing materials, that's our secondary equation. Yeah, so that's kind of like the perimeter. It's like going around the shape, right? So let's talk about what all these are. 2R plus H plus half the circumference plus another H, right? Okay, so we got 2R plus H plus half of the circumference. So half of what's circumference? 2 pi r plus H is all equal to 12. So that's going all the way around. You guys see it? So we had 2R plus H plus half the circumference plus another H. We went all the way around. With me? So we need to solve for either R or H. So as I start simplifying, I'm like, ooh, I got 2R, 2H, pi r equals 12. So what are you trying to solve for? Are you trying to solve for R or for H? There's one that's easier. Definitely getting H by itself is easier, right? Do you guys see that? Yeah. So I'm going to have 2H equals 12 minus 2R minus pi r, and then I'm dividing by 2. So I could write that as 6 minus r minus pi over 2r, which is okay because we're going to multiply by 2 in a second anyway. So it'll be nice.
Did you rearrange the secondary equation?
I did. I rearranged the secondary equation, yeah. Okay, so now we go here and we're like, oh, I don't want to have R's and H's. I wanted to get rid of that H. And so I replace it with this. So I'm going to have A equals 2r times 6 minus r minus pi over 2r plus 1/2 pi r squared. It gets messy for a second, and then it'll be okay. We can power through, I promise. Powering through. Okay, so pi r squared, is that what that is? Yeah, pi r squared plus 1/2 pi r squared. Do you guys see what I got? So 12r minus 2r squared plus pi r squared plus 1/2 pi r squared. So I could even, like, if you want to combine these, like, you could combine those. What would you get when you combine a negative pi r squared plus a positive 1/2 pi r squared? Yeah, you get negative 1/2 pi r squared. So if you want to do that, go for it. Or you can just take the derivative from here. Maybe I'll combine them. Sometimes we forget things like that, like we forget to combine, but it's fine because you're going to take the derivative anyway and it will work out. So now we have A prime equals 12 minus 4r minus, who can tell me the derivative of negative 1/2 pi r squared? Negative pi r, good. Yep, negative pi r. Because that pi is just a number, right? I don't think it's a variable. It is a variable, a Greek variable. Or not a variable, it's a Greek letter, but we use it as a constant. All right, so here we go. Wouldn't that be fun? Smiley face? Yeah. I've done that before with like my Algebra 1 class. I've been like, what's 5 times smiley face plus 2 equals, 10? You have to figure it out.
Instead of theta, smiley face.
Yeah. All right, here we go. How do I solve for r? So I can subtract the 12 over. I can divide by a negative if those negatives bother you. I pull out the r, so I get 4 plus pi. So my r is equal to, no, 12 over 4 plus pi, yeah. And I don't like that, so I'm going to find it as a decimal, because we know on the AP test, we can round. Lydia, to how many decimals? She texted me and only had 2 decimals. I was like, I'm screaming 3 decimals over the phone. 3 decimals! All right, 1.680. All right. So now that we have that, we go back, we're trying to find the dimensions. So our dimensions are going to be, we plug in r equals this. This was in meters. Pretty big window. So we're going to find h equals, I made a mistake in first period and it was like 30 meters. I was like, I did something wrong. Please find my mistake. And Jacob was like, oh, well, you actually messed up in the first line. I'm like, Jacob, this is why we have bonus points. Like, you need to tell me. I forgot my squared, like, on one of the, I don't know. All right, so h is going to be.
See, it's funny that like you did it wrong and then it went to a really fun number.
I know, like, it wasn't nice. It was like 30 something. I'm like, there's no way my window is 30 meters. Like, that is a massive house. 30 meters, like, bigger than this classroom and Anna's classroom.
Well, I mean, like, Fairbanks has some pretty big windows.
So it's a wall of windows. Who knows? I mean, that would be a really weird Norman window, right? It'd be a weird Norman window. All right, so yeah, these are our dimensions. So remember, you can always show that it went up and then it went down for your A prime. But I found both, yeah. So if you plug back into here, plug your R back in, you actually get the same thing. That's why I mentioned before, remember, it's not actually a square though. Look at it. What is it? It's a rectangle because it's 2R along the bottom. So, but then it ended up being the same. All right. So then there's one last question. We're not going to do this, but just look at it. So we have profit, revenue, and cost.
Oh, God.
Do you guys remember the relationship? We talked about the lemonade stand way back when. Yeah, so revenue is like the amount of money in the jar. Cost is how much it cost your mom to buy the lemonade, so you're going to pay her back like a good kid. And then profit is how much you have left, right? Yeah, so you could do those as well. We don't have any of those on your homework, though, so we'll just not do that.